the final exam, we go to question number 1. Let's say which option is correct. The truss is made of bars. So this is option B. The right answer is B. Number 2, there is a mass sliding down this 20-degree line, and this is your mass M, so you have friction, nominal force, and what they're asking is say what option is correct. Obviously, if we draw a figure for that, you have mg, and this is 20-degree, F and N, so you get summation of force here, say this is x plus summation of force in x 0. Then what you get mg sine 20 positive negative F is equal to 0. And we know that this is actually moving, but the velocity is constant. So still the acceleration is 0 and the law of equilibrium is valid. So this gives us F is equal to mg sine 20. And meanwhile, because it's moving, the friction is equal to mu k, the kinetic friction coefficient times n. So these two conditions are valid simultaneously. So it's going to be B and D, which is option B and D both together is option F. Option F. B and D. And we go to the next question. Let's say write down the 3 steps we solved the equilibrium problem. What was the 3 steps? Step 1, choosing system. Step 2, drawing FED. Step 3, writing the equations. Step 4, solve them. Step 5, verify your solution. The 5 standard steps that you take to solve the problem. Now, go to question number 4. Question number 4. You have a truss, and it's a little bit difficult to write. Try to write quickly. So you have point B, C, and from here to here is 1 meter. 1 meter. Everything else is 1 meter here, and so these are the square root of 2, the diagonal. Okay, and point CDA, B the ruler, 10 kg. So this truss is given to you. And the first thing you say, it says, let me double check, make sure exactly this is what we have here. So these are the joints, and right here, the, yep, that's it. So the first part is safe, identify zero force members. So in order to identify zero force member, this guy has external support, so these two are not zero force members. Here you have 1, 2, 3, 4 members connected with pin, so it's not zero force member. Here is three members, but they're not aligned. Two of them must be aligned. So this is not zero force member here. Nothing here, nothing here, nothing here. And these two members connected to a pin, no external reaction. Both of them are zero force members. Right? Now if you come here again, 1, 2, 3, 4. No zero force member here, no zero force member here. Now here again, 1, 2, 3, 4. No zero force member, no zero force member here. Nothing here, here. 3 members connected to a pin. 2 of them are collinear, no external action. So the third one is zero force member. You come here, the same thing here. 2 of them collinear, the third one is zero. No zero force member here. Here, 2 of them collinear, the third one is zero. So if the third one is zero, right, and still you have this guy connected to this, connected to this. So nothing, no zero force member here. Nothing is here. Nothing is here. Nothing here, nothing here, nothing here, and here, this is your zero force member. That's all. So I have 1, 2, 3, 4, 5, 6, 0 force members. 0 force members. Now, even if you don't write 6 0 force member and you just circle it, it's acceptable. The next part, it says, find the force in this particular member. Right? So what should I do? First, I check the entire thing as a system. I take the entire thing as a system. There you go. And then I draw a 3D. And you have Ay, AX, and then the gravitational force, these are the surface force, right? The gravitational force is 10 times 981, which is acting at this particular direction at this point on the system. So these are surface forces for the system. This is body force that acts at this particular point, right? So in order to find, my idea, my goal is first find Vy. Well, once you find Vy, then you can section here, and then you can take the right part of section structure. So you get 3 unknowns. 1, 2, 3. Then you can find the force in this member by taking the right section part of the truss, method of section. Right? So in order to find Vy, I write summation of moment at point A, 0. Then I get 10 times 981, 1 is 98.1, and times this distance from here to here. Right, this moment on, but you bring it down. This distance is 1, 2, 3, 4. Positive or negative, the moment is negative. Plus moment from Vy times from here to here, which is 1, 2, 3, 4, 5, 6. Is equal to 0. So that will give you Vy is equal to let me grab have a calculator, I don't have a calculator. Do you have a calculator I can borrow? Thank you. So, 4, and 8.1 divided by 6. You get the fraction, the decimal, this fraction converted.
Yeah, so
Yeah,
you
put it on more decimal.
you just click this on.
Thank you. That's good. Appreciate it. So dy is 65.4 in Newton. 65.4 in Newton. That's By. Now the question is, do I really need to find X and Y? The answer is no, because if I do section, method of section, or if I, in other words, if I cut it here and take only the right part, I have nothing to do with the left part. So that's the reason it saves time. I won't find X and Y. Right? I'll just immediately go to the right, the structure. So if I go to this system now I'll change my system. And I already have dy. And once I change system, what should I do? Try FPD. Write equation, solve, verify. Do everything again. So if you want to draw a FPD for that, you already have dy and you know the value. You have this guy which is 98.1. And then here you have FTC, a force, let's call it F1, a force in this member, and a force in this member. Let's call it F2. That's what we're trying to find. F2 is equal to FCD. Right? And then you have force here, let's call it F3, F2, F1. And we want to find F2, right? So this is my FPD for this system. So what should I do next step? Write the equation. What equation can I write to get F2 only? The answer is summation of force in X0 for this system. This will immediately give you F2, right? So if I do that, sorry, in Y, summation of force in Y0. That will immediately give you F2, because F1 and F3 are purely in the X, right? So if you do that, you get F2 times sine, this angle is 45, right? Because these are the same. So this angle is 45. Sine 45, F2 sine 45, positive or negative? Negative down. Nothing from F1, nothing in the Y. But this is in X, nothing from F3. And then you go here, negative 98.1. And then you go to this guy, plus dy, which is 65.4 is equal to, this is all, is equal to 0. So that gives you the answer. F2 is equal to 98.1 minus 65.4, close parentheses, divided by sum 45. Divided by sine 45 is negative. So it's negative 38.4, 3 significant digits, Newton. So it's compression. So this member is in compression, and the value is 38.4. Let's see, it's still recording. Yeah, it's still recording. Now let's go to the next question. Next question. Say, draw FED for the frame. So this is your frame. Let's try make it small. So this kind of your frame. We have a cable here. A, G, another in here. F, C, D, 2K, E, P, A, B, C, F, E, D, 2K, and this one is H that is connected with cable to the wall. So the first question is, it says, obviously this frame has 4 beams. 1 beam, 2, 3, 4. You can label it here. You can, for example, say this is beam number 1, beam number 2, beam number 3, beam number 4. It only has 4 beams. Right? Let's say draw three-way diagram for the entire all the 4 beams. Right? So in order to do that, I can just simply make it like that. Explode it. Sometimes we need to explode the stuff in order to get the solution. So this is 1, 2, 3, 4. And then I go ahead and draw FED. I put EX, EY. Don't forget to put opposite here, because we only have 1 pin. 2 parts connected to 1 point. So EY, EX. And then here you have the 2K, which is known. This is not a biggie, because you have it. And then at C, go ahead and put CX, CY. And don't forget to put opposite CY, CX on member number 4, right? Then at B, you have VX, VY. And at A, you have AX, AY. Put the opposite here, AY, AX. Now here, you have a tension in the cable that's connected to wire, right? Do I have the tension? No, so I just call it T. So this is unknown, right? Then you go here, GX. Is that G? Yeah, GX, GY. Put opposite GX, GY here, and this point, call it FX, FY. Put opposite here, FX, FY. And that's your free-body diagram for all four. So here, you have 2 unknown for reaction here, you have 1 known, 2 unknown for reaction here, 2 unknown for reaction here, 2 unknown for reaction here, T, and 2 unknowns here, and 2 unknowns here. So this complete free-body diagram. So how many unknowns do I have? Let's go ahead and count them. So 1, 2, still 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, 7, 8, 10, 9, 9, 10, 9, 10, 11, 12, 11, 12, 13. So number of, this is the answer to part B. So the answer to part, this answer to part A. See how small it is? The space that I put here is more than enough. We go to answer part B. You say, in fact, part C. Before we go part B, because part B is some calculation. Before we actually do calculation, we go part C. Here, to say how many unknowns you have, how many equations. Number of unknowns, unknowns is equal to 13. I just counted, right? 13. You can also say where you have 1, 2, 3, 4, 5, 6, 6 pin. Every pin has 2 unknowns. 6 times 2, 12. Plus 1 cable, 13. Right? 12 plus 1, 13. And that's the reason that I said as soon as the cable is perfectly flat, so you don't have X and Y component, you have just one unknown. Right? So number of unknowns is 13. Number of equations. Number of equations. How many equations do I have? Well, I know per part I only have 3 equations. It's a dimensional problem. So per part I do have, I do have 3 equations. So I have 1, 2, 3, 4 part. 4 times 3 equations per part is 12 equations. So I have only 12 equations, but I do have 13 unknowns. So the part C say, can I solve for all of them? And the answer is obviously no. You may be able to find some of them, but not all of them, because you don't have not enough equation. You see that? Number of equation is less than number of unknown. So cannot solve for all. And as I said in the class, this problem is indeterminate, or they call it statically indeterminate. That means using equation of vector static, we cannot solve all of them. However, we should be able to solve 1 or 2 or 3 or some of them, right? And that's the thing in this answer to C. Actually, part C, not B. This answer is part C. And part B is say find only T. That's what part B is asking. In this structure, it says find the tension in this cable. Right? So, what should I do? Let's write it right here. So the answer to part B. Now work in part B. Well, this is one way to put all the equations together and use Gaussian elimination to solve everything, to eliminate all the things and finally get T. Another way is just change the system, right? I have 4 systems here. Just take one system, take the entire thing as a system. Just one system. If you just want to find T, because this comes some sort of like external reaction. You see that? So if you do one system and draw FPD, you have a 2K, and this is your external force here, right? Then you have a Bx Py, and then you're gonna have a T here. That's your FPD for the entire thing. You see? How many unknowns do I have? 1, 2, 3. How many equations do I have? I only have one part. So one part, 3 equations per part. So 3 equations, 3 unknown. Can I solve it? Yes. I can find T and Bx and By. Right? How can I get T directly? Right? Summation of force. Summation of moment. About point B must be 0. Just one moment equation is enough. So what you get? Nothing from Bx, nothing from By. You get 2K times this distance from here to here. What is that distance? Well, in the class I said this is 1, this is 1, this is like equal space. They're all 1. And this also 1, this is also 1. The same proportional. And this is also along with that. Right? So if this one, the distance between 2K and B is 2. So you multiply by 2 and it's negative. So the moment, this is the moment from the port 2K, right? Nothing from Bx, nothing from By, but they go through that point. And then the moment from T. What's the moment from T? Move it to the right. So it's this distance, which is 1 times T. Positive or negative? Positive, because T is this way. Is equal to 0. So what is my T? T is equal to 4. Take it to the right. Kilo Newton. That's the answer to part B. You see, everything is just one line. It's pretty easy. Now, let's go to the next question. Question number 6. You have a geometry like that, and it's asking to find, so the centroid, if I don't have this guy, the centroid is exactly in the middle, right? But with that appendage, then my centroid will shift a little bit right here toward that added area. So the centroid will be somewhere here. So that's the centroid of the entire shaded area. So what this question is asking is say, find the area moment of inertia with respect to this axis, the y-axis that goes through centroid. Don't forget the bar means the centroid. So I'm trying to find my bar. That's what I'm trying to do. So according to what we discussed, we first have to break it up. The way I break it, you have a lot of different ways you can break it. I'll break it into shape 1, shape 2. That's the way I do it. You could just simply say this is 1, from here to top is 2. Right? You could say this is 1, right? This is 2, and this is 3. 3 shapes. Right? It's all up to you what you want to do. So let's put the dimensions here. The dimensions here is this is 1 mil. This is 5. This is 5. And the entire thing from here to here is not the entire thing, from here to here. From here to here. Not the entire thing is 8. Okay? So 8, 5, 5, and 1. That's all I have. So the idea here is first find the centroid, because I don't know where this point, how much this point is deviated from here, right? So after I find the centroid, which I actually have the formula, it's given in the appendix, right? Then the next step is find each one of these subshapes. They have their own moment of inertia. How can you find it? The formula is given here. Find their own moment of inertia with respect to their own local centroid, and then at the last stage, use parallaxis theorem to transfer everything to y bar. When you transfer everything to y bar, then you can simply sum them up and find I y bar for the entire shape. So let's do that. First you need to find X bar. So this is X bar, Y bar is the central coordinate system. So first, I need to find this distance, the left. You could just take your reference from here. So that's going to be this distance. It's just all up to you. So I take my reference from this base, and therefore this is the X of the centroid, X bar. And now this is from here to here, it's going to be Y bar. Right? So in order to find X bar, I simply make a little table shape. Let's see if it's still recording. Got some memory limitation. Yeah, it's still recording. So shape number 1, let's use Roman characters. Shape number 2, right? And then you have, first you need to find area and each own X bar I and AI X bar I. So sum of this column divided by this sum of this column, this two sum is going to give you the X bar. And then we add more column to here, to this table, to get Y bar of each one, I bar of each one, and the distance and parallel axis theorem, and finally we sum them all together. So let's put this down. We have the formula in the appendix, I can use it. So for shape 1, the area is 1 times 10, right? So it's 10, and then this is simply millimeter. I don't repeat it here, I just put it here. Millimeter squared. And the final answer, I asked to find millimeter to the 4th power. So you're all set, you don't need to convert anything, right? So 10 times 1, 10. Shape 2, the area of shape 2 is 8 times 5. 40. So the total area is 50. Alright. X bar 1 with respect to this base. So for shape 1, the centroid is a half, so it's half 0.5. For shape 2, right, is here. So it's half of 4, half of 8, which is 4, plus 1. So it's 4 plus 1 is 5. Alright? Now multiply this together. So this is going to be 5, and this is going to be 200. And this is going to be 5. So if you sum them up, 205 and 205, 205, and then you divide this together. So your X bar is equal to 205 divided by 50. With a calculator. .1. 4.1. That's what you get. So from here to here is just 4.1. Now I go ahead and add another column here. IY bar. IY bar, but for each specific shape with their own local centroid. So the axis is going through this point, the axis is going through this point. The local centroid. We're not talking about the actual IY bar, right? So this column you get for this shape, right? You go to that appendix, and then you see this is a rectangle. So with respect to this axis, it is 112 times this base, which is 10, times the height, which is 1 to the 3rd power. right? So don't forget, we're not taking this axis because we are taking the y bar, right? It's not x bar, that's the opposite. Now you go to this shape, then you have 112, again, we are doing this, right? 112 times from here to here, which is 5, times from here to here, which is 8, to 3. Right? 112, 5, 8, 2, 3. So let's put the number here. I wish we could, let's extend it here. Let's extend it, make a little bit, I wish I could write to the right. So I continue this table up here. See if I can continue like that. Alright. So the value for that, put in a calculator, is 10 divided by 12, which is this guy becomes let 0.8 3 3 3. Right? This one, if you put it in a calculator, you get 5 divided by 12. So you get this one becomes 213.3. Right? So now this is the information. Now what I need according to Parallax's theorem say I with respect to any axis is the one that we want to transfer. Is the I local centroid, this one and this one, plus its shape, the distance between these two axes, square, right? So this is what I have. So I already have this one, right, in this column. What I need, I also have AI. What I need is a column for D, and a column, so this is the same thing, but table continues. This is just continuation of same table, right? So I put distance DI for each shape. 1, 2, total. Right? So for shape 1, this one, what is the distance between local centroid and the actual centroid for the entire shape? Well, obviously, is 4.51 from here to here, subtracted by from here to here, which is 0.5, subtracted by 0.5. So 4.1 subtracted by from here to here, which is 0.5. So this is one value. Now let's go to shape 2. Don't get yourself distracted with putting this in the calculator. Let's first write it and then you can put it in the calculator. Now you go to shape 2. What is the distance between its own centroid, which is here, and the total centroid? Well, it's from here to here. You see that? That's E2 for shape 2. So what is that? That is from here to here, which is the center of that is 8 divided by 2 is 4 plus 1. 4 plus 1 is 5. So it's 5 minus from here to here, 4.1. 1. So now let's go with the calculator. The first one, even if you know is 3.7, just put it in 4.1 minus 3.6, and the second one like that. Alright, so we have that D. Now the last column is I bar plus AI DI squared. Just parallaxes theorem. Now, if the final answer to the question is simply sum of this column. Because why? Because they are transferred to the total centroid, so we can simply sum them because they are taken with respect to one reference point, right? So let's do that. Y bar 1, which is 0.8333, 0.843 plus, put plus here, plus A1, which is 10 times B1, 3.6 squared. That's what you put in the calculator. The second one, IY bar 2, which is this, 2, 13.3 plus A2, which is 40, times D2.9 squared. Let's put it in the calculator. So you get 0.8333 plus 10 times. So I get the first one is 130. Point 4, and the second one 213.3 plus 40 times 0.9 times 0.9. Then I get 245, 245.7. 245.7. So the final answer, no, this is this is the answer for that, right? 245.7. Now the final answer is just summation of these two. So 130.4 plus 245.7 gives you 376.1, which to the three significant digits that what we want is just 376. What's the unit? Because we use our millimeter, it's just millimeter to the fourth power. And this is the answer to the last question. As you can see, it was a pretty easy exam. I saw some people did it in 40 minutes, some students, and they pretty much got all the questions. So, well, I think that should be all. All right.